Welcome back. In the previous video lecture, we have discussed about different restructuring models of power systems. And in the last self-learning video, we have seen the functions of independent system operator and also the principles of independent system operator as laid by Federal Electricity Regulatory Commission of USA. We have seen that independent system operator is supposed to perform 11 principles. In this video lecture, we will see what are the different activities of independent system operator in restructured power markets and also how he handles emergency conditions. I hope by the end of this video lecture, you will be able to list the objectives of ISO, ancillary services offered by the ISO, and I hope you will be able to explain the handling of transmission constraints and emergency conditions by ISO. Now, starting with the basic purpose of ISO as discussed already, his major job is to ensure a fair and non-discriminatory access to transmission services and ancillary services. And one more job for him is to maintain the real-time operation of the power system. He must check in that all the load flows which have been committed or as per the schedule and delivered to the customer. And also, he must facilitate the reliability requirements of the power system. He must ensure that everything is going as per the standards, and he must check the voltage, power, and other aspects of the power system. So he must be very independent of the market participants, which means that he must not own any Genco, Transco, or Discom, or he must not be part of any company which involves in these activities. So being an independent operator, his basic purpose is the three things which I have mentioned here. Now, the objectives of ISO. As discussed already, the primary objective of ISO is not about dispatching or redispatching generation. His major job is to ensure that the power system is reliable during the transmission of power. So he must ensure that the electricity supply is met with the demand. That is the first and foremost job which he is supposed to do. In case of any exigency, he must take additional measures in order to balance his supply with the demand. So he must be able to control the generation to the extent which is necessary. Let us suppose if demand is not there, he must control the generation. And he must take necessary steps to ensure that the transmission sector is working efficiently. And also, time to time, he must monitor the performance of the transmission system. That I think I have mentioned here. He must evaluate the condition of the transmission system. And let us suppose if somebody asks for any request for the transmission services through some bilateral contracts or in some pool markets. Pool market defaultly ISO delivers it. So ISO basically independent system operator handles operations in pool operations. Whereas in bilateral contracts, whenever he gets any request from a bilateral transaction, he must approve or deny the requests for the transmission services. This approval or denial of the transmission services is based upon how he maintains the system integrity. So, and the most important thing, as we have discussed in our last course also, that frequency maintenance and voltage maintenance are the two important things which are to be looked after in order to ensure the stability and reliability of the power system. So that job also will be taken up by the independent system operator. The functions of ISO. Now let's have a look. We have gone through in the last video lecture the principles of ISO which have been laid by the FERC. Now we have understood what are the duties of an ISO. Now we will see on a large scale what are the functions of an independent system operator. I have listed somewhere around 14. So let's have a quick look about these 14 functions of independent system operator. The first and foremost function of an ISO is he must schedule the electric power input and exports. So whatever the power which is coming to the pool and whatever the power is going out of the pool, he must schedule the transmission sector. He must schedule the generation and demand also. It doesn't mean that he is supposed to schedule the generation and demand. He receives the bits and thereby he finalizes, thereby gives the instructions to both the generators and the demand. So based upon that, he schedules electric power import and export. And also, most of the times, let us suppose if we take a large country like this, there might be different areas which will be covered by this. Even in US, I think there are somewhere around 12 to 14 separate electricity markets. Let us suppose this is a country. This is market 1, market 2, market 3. Every market holds basically separate independent system operator. So an ISO in independent system operator in market 1 should maintain healthy relations with other operators, other markets also. And he must coordinate because sometimes the power may not be available in this region. He is supposed to fetch power from some other region. So ISO will be having control over this sector only. So if he wants power from other region, he must coordinate with the ISO of this region and also ISO of this region. So the second point which I have mentioned is interconnecting with other transmission grids and coordinating with other ISOs. And in this sector, let us suppose in this region itself, if somebody asks him, he must be able to fulfill the requests for transmission services. And whatever he approves or denies, he might approve or he might deny the service based upon the maintenance of system security and reliability. So once he approves or denies, whatever the information is there, that entire information of what is being scheduled on the transmission lines, etc., that must be very transparent. So that information should be transferred, should be disclosed to transmission users and sharing information with other ISOs. So that information should be shared by everyone. And also, he must monitor real-time flows on the transmission grids. And next is, if at all, if there are any transmission constraints in the system, he must identify them and he must take necessary measures. So what type of measures I have listed here? This is identifying transmission constraints. So he will try to access other transmission resources if they are available. The next is, let us suppose this is the case. If let us suppose generation is too high when compared to the demand. So demand has sudden fall in demand. So if there is sudden fall in demand, what you are supposed to do? You must lower the generation immediately. So limiting the rescheduling of generation to maintain the reliability. That is the job which he is supposed to do. And let us suppose if the system is not stable, then automatically you are supposed to dispatch your ancillary services. What are the different ancillary services? You are supposed to ensure Q, V, F, etc. All these things, they come under ancillary services. So the ISO must dispatch these services to ensure system reliability. And as mentioned earlier, you must curtail specific generation transaction in order to maintain reliability of the system if the demand suddenly locks out. So in case of bilateral transaction, you must determine if there is any feasibility of bilateral contracts and spot market transactions also. You must ensure the feasibility of these type of transactions. Now, apart from this, in case the demand suddenly comes up, then you must be having additional generation. You must be having some persons who are supposed to provide additional services for you. Those people are called as basically spinning reserves. So you must be capable of providing system security and spinning reserves. And also, you must perform metering and data collection activities and maintain these data. This will help you for analyzing or forecasting the future demands, etc. And when you are offering services, whether it is a transmission services or providing access to transmission services or ancillary services, whatever the services which you provide, for all those things you are supposed to collect the levies and taxes for offering services. And finally, if anybody is not working properly, you are supposed to initiate some disciplinary action against them. And if somebody is working very efficiently, you must provide some sort of incentive for them. That job also is to be done by independent system operator. So these are a small list of functions of independent system operator, but you can list any other functions which you find that they are relevant for this one. So if you carefully see, this is a document which I have copied from a textbook on restructured electric markets, Shaidapur textbook. The author of is Shaidapur. Now, if you carefully see this one, what is the role of ISO? The first thing is he must match load and supply, and he must take care of the power exchange. In power exchange, what he is supposed to do? He is supposed to collect the bids, match the bids, and next he sets up the system price. Once he sets up the system price, he informs the generators and discoms, right? And he ensures fair use of transmission network. So he collects requests. So he ensures the fair use of transmission network. And for those who have used the transmission network, he will collect the transmission charges and congestion charges. This is an ancillary service, so he collects congestion charges also. And this is also an ancillary service. He will compensate for the loss if it is asked. So these are ancillary services, and this is the transmission service, and charges will be collected for that one. Apart from this, he forecasts the load because that is required in proper planning of the system. So he forecasts the load and he maintains system security. How he maintains system security? By he maintaining spinning and non-spinning reserves, or he will provide these ancillary services also. And he maintains relations with separate markets, and he takes care of the losses and also the reactive power. These also they come under ancillary services. So these are the few functions what the ISO does in restructured power markets. Now, the different structures of ISO basically, ISO can take up different structures as we have already said. The common structures are two structures. One is the first structure where he maintains only the transmission reliability. That he maintains the transmission reliability by operating the power markets to the extent that ISO would schedule transfers in a constrained transmission system. This type of market is basically called as bilateral contracts markets. The other market is this second structure is a pool market where you are supposed to do the entire job. So, and these are the list of ancillary services which are offered by the independent system operator. One is he schedules, controls, and dispatches the services, and he also ensures that Q and V are in the ranges, approved ranges, and he also takes care of the frequency and regulation, and its regulation ensures that frequency is up to the mark, and if in case of any imbalance between the generation and demand, he ensures that they are being properly maintained, balanced, and in case of there is any sudden requirement of power, then automatically he should maintain reserves. So operating reserve, spinning reserve, supplementary reserve, all services he is supposed to maintain. And finally, if at all if there are any transmission constraints, he must be in a position to mitigate the transmission constraints. So these are the services which will be offered additionally apart from providing non-discriminatory access to the transmission services. See, the first one is regular function, scheduling, controlling, and dispatching services. Now, reactive power and voltage, frequency, energy imbalance service, and in case if it is required suddenly, he must provide reserves, and finally, transmission constraints. Just like transmission congestion, etc. Those should be done. Okay. Now, that's it for today. This we will discuss in the next video lecture regarding the handling of transmission constraints by independent system operator. Thank you for today.